Okay, Anita is the host now, so whatever you want, you just ask her. So I'm going to start with the questions we had last time before entering into whatever we need to do today. So I don't know if everybody went through the questions, but we'll start from the first one. The question is in the class group. The question is in the class group. So okay, no, I'm not even gonna start with. I'm not gonna start in order. I'll start with database maintenance. So according to you guys, or if you guys went through the questions or went through chapter 12, and does anybody has an idea of what database maintenance is? So database maintenance is the activities used to keep the database running smoothly. Database maintenance are simply the activities used to keep the database running smoothly. When I talk about activities, what do I mean? An example of an activity that you or I can use to keep the database running smoothly: freeing up spaces, troubleshooting or looking for bottlenecks. So what is the aim of that database maintenance? The aim is to improve the performance of the database. So I'm going to start back. Database maintenance are simply the activities used to keep the database running smoothly with the aim of improving the performance of that database. Okay, so as I move forward, anybody has a question, just let me know. So the next one we're going to see is database performance tuning. What is performance tuning? Performance tuning is simply the activities that you as a DBA can take to optimize the performance of your database or to ensure that the database is running as smoothly as possible. I repeat, what is database performance tuning? From what I'm saying, you can see that there's not a lot of difference between database maintenance and database performance tuning. So performance tuning are simply the activities that you as a DBA can take to optimize or to increase the performance of your database to ensure that the database is running as smoothly as possible. Okay. Next is optimizer statistics. So we're doing the class together. I'm not doing it alone, so I'm expecting you guys to participate. Optimizer, okay, optimizer statistic. What is optimizer statistic? Anybody has an idea? Optimizer statistic. Okay, so optimizer statistics. Okay, first of all, what are statistics? So according to you, what are statistics?
It's a collection of data gathered in a database.
Okay. Someone else? Okay. So as I used to say, for example, if I ask you about statistics, you should not at all costs bring it or relate it to the statistics are simply the collection of information for whatever purpose you want or for whatever aim you want. Statistics are simply the collection of or the gathering of information. So optimizer statistic is the gathering or collection of statistics to know how much input and output are required to execute a SQL command or a SQL statement, a particular execution plan. So it is a gathering or collection of statistics to know how much input and output and even memory, how much input and output and memory are required to execute a SQL statement with a particular execution plan. With a particular execution plan. Okay. Can someone just explain to me what he or she understood about database maintenance?
From what I understand, database maintenance is, for example, like if you maintain your car, you actually you go and double check to ensure that everything is running smooth, and even if something look a little bit abnormal, you try to fix that before it actually occurs. So what I understand is like being proactive and trying to solve an issue before it actually occurs.
Exactly.
Right, I can say the same thing. Is the action we take as a DBA to fix potential issues so that the database run efficiently.
Yeah, thank you. So this is for database maintenance. Okay, let us go back to optimizer statistics. Um, Optimizer statistics are gathered, like when are they gathered? Like when are optimizer statistics gathered?
Every 24 hours.
And for how long are they gathered?
For 7 days,
30 to 31 days.
Thank
7
you.
to
They're
8.
gathered for 30 to 31 days, depending on the, like when I mean 30 to 31 days, that means that what if next month has 30 days, then you gather the statistics for 30 days. If the month after next month has 31 days, you gather the statistics for 31 days. So optimizer statistics are gathered every 24 hours for 30 to 31 days.
Is that the default days?
Is that the default days?
Like, is it a default? That's a default days, or can you adjust those days to your convenience?
No, I don't think so. I don't think so. Maybe, maybe not, but I don't think so.
Okay.
So the next one is database statistics. So according to you guys, what is database statistics?
From what I understand, database statistics are basically uh, the changes in the changes that occur in the database. Those statistics are being gathered. I mean, from my understanding.
Okay. Okay, so database statistics are simply the collection of or the gathering of information to improve the performance of the database. Like, let's say the main aim of database statistics, the main aim why we collect database statistics is to improve the performance of that database. And those statistics are gathered every 60 minutes and they are kept for 7 to 8 days. Database statistics are gathered every 60 minutes and are kept for 7 to 8 days. And you know that the database statistics are stored in the AWR.
Right.
Database statistics are stored in the AWR. Talking about AWR, what do you guys understand by AWR report? AWR, automatic workload repository. What do you guys understand by AWR report?
It's an infrastructure that provides service to Oracle server component to collect, process, maintain, and use performance statistic for to detect a problem in a database.
He's correct. So the AWR, the automatic workload repository, is simply a built-in repository in every Oracle database that collects and maintains statistics for problem detection. So in that database, like they said, AWR is a built-in repository in every Oracle database. That means that in that database, the AWR is found in the 6aux table space. AWR reports are found in the 6aux table space. So it collects and maintains statistics for problem detection. Okay. Can someone just repeat what I said about the AWR?
All right, can I say then? We said the AWR, which is the automatic workload repository, is an infrastructure that help gather, collect, process, maintain, and use performance statistics for problem detection, and it is stored in the 6aux table space.
Thank you. So the next thing we're gonna say is the ASH. ASH, which means active session history. So it is simply the history or the history of okay, it is simply the history of the activities that happens for a specific session. For example, if you guys went to your enterprise manager on okay, I don't know, it's not performance. Besides performance, there's something. So you're gonna see your top sessions.
You're right, under the session, yes.
Yeah, you're gonna see your top sessions. So the active session history simply has the history of the activities that happens in a specific session. So it keeps the samples of the data. It keeps the samples of data. I guess everybody knows what we mean by samples. So the next thing is ADDM. I said as I move, if anybody doesn't understand something, I'm expecting you guys to ask questions. So the next thing is ADDM. Can someone give me the full meaning of ADDM?
Hello.
Automatic database diagnostic monitor.
Oh, cool. I tried for you yesterday. I know you.
From what I understand, the ADDM, you mute that person.
Anita, please, can you mute that person?
Thank you.
From what I understand, the ADDM, it analyze the data that is gathered by the AWR and provides possible solutions that can be used to improve the performance of the database.
Exactly.
If I can add to Devon, so the ADDM reviews the performance of the database every 60 minutes. So it automatically runs after each AWR report. I mean, AWR snapshot.
So you're correct. The automatic database diagnostic monitor is simply a software that analyzes data in the AWR. So it's just to say that there's no ADDM without AWR. There's no ADDM without AWR. So it locates possible performance problems, and it is taken every time an AWR snapshot is taken. As I said, there's no ADDM without AWR. There's no ADDM without AWR. And it is taken every time an AWR snapshot is taken.
It's taken.
So the next one is AMM, automatic memory management. So according to me, if anybody has an idea of what issue of the AMM.
You mean the meaning?
No, like
what does it do? Oh, it if anybody can take it.
Okay, so it simply manages memory. So you guys can see whenever you want to create your database on DBCA, they will ask you, or you will see a box where you can check enable automatic memory management.
Right.
So whenever you check that, your database automatically manages your memory. That is, the database knows which memory needs. No.
He allocates
what
the
size
memory.
of memory needs SGA? What size of memory needs PGA? So it allocates the memory accordingly, automatically. So this is for the automatic memory management. I guess everybody has seen it when creating the database on DBCA.
I think we also at some point we went to the P file and comment out the memory. Is that a part of enabling it too?
Okay. So the next one is ASMM. ASMM as in automatic shared memory management. Anybody has an idea of what it is?
I think it's the same. That
okay,
one is, the first
exactly,
one is automatic memory.
It is kind of the same, simply that the ASM is a feature meant to adjust the size of the SGA whenever the workload changes. So the automatic shared memory management is simply a feature meant or used to adjust the size of the SGA as the workload changes. Yeah. So anybody has a question? Okay. The next one is huge pages. So what is huge pages according to you?
So huge page enable when huge pages are enabled, it makes it possible for the operating system to support memory pages greater than the default 4K.
Okay. Okay, you're
4
right.
kilobyte.
You're not wrong. So according to me, or what I heard about the huge pages is that it is a Linux feature that allows the operating system to support memory pages greater than the default. So it allows the operating system to support memory pages greater than the default, and it improves the operating system performance when running the Oracle database with large SGA sizes. So it is kind of a I mean, I don't know, but it can be a server tuning, something like that. Okay.
Say it again, Renata. Say it one more time.
I'm not sure, but I think it can be a server tuning if it improves the operating system performance. Okay. So the next one is SQL profiles. The next one is SQL profile. So SQL profiles are simply the set of specific information to a SQL statement. They are the sets of specific, or you can just say they are auxiliary information to a SQL statement. And they are used to improve execution plans.
Right. What I got is it's a database object that contains auxiliary statistic specific to a SQL statement. And like you say, like you say, it's used to improve an execution plan.
Okay. So as Prof was asking us last time, if you want to relate, you can relate SQL profiles with application tuning. That's what I think.
That's correct. I got it too.
You can relate SQL profiles with application tuning. So the next one is SQL baseline. So what is SQL baseline? SQL baseline is simply a set of accepted plans. And you need to note that whenever these plans or these statements are passed to the optimizer, he chooses the best, the best plans. I repeat, the SQL baseline is a set of accepted plans. Full stop. But if you need to add something, you can just say that when these statements are passed, the optimizer chooses the best plan. The best plan. Okay.
What I got is the SQL baseline help the DBA manage and control the execution plan that the optimizer generate for repetitive statements. I don't know if it's.
Can you repeat it, please?
So the SQL, the SQL baseline help the DBA manage and control the execution plan that the optimizer generates for repetitive statement.
Okay. So, okay. Okay. The next one is index. What is an index? What is an index? I'm asking the class, the question to the whole class.
All right, I got it from Prof. He said an index helps speed up a query by pointing us to a specific row to get the data quickly.
Okay, yeah, you're right. So according to me, an index is simply a schema object that provides a quick lookup of data in a column or columns of a table. An index is a schema object that provides quick lookup of data in a column or columns in a table.
I got a question.
Hello.
So what's your understanding or the difference between the Oracle optimizer and the query optimizer?
Oracle optimizer or query optimizer.
Are they the same thing or what's the difference?
Okay, when Prof comes to ask, I have no idea.
Okay, all right, thanks.
Okay, talking about Prof. I think Prof is there already.
Yeah.
Okay.
Keep going, Ronaldo.
Prof is there. Okay. So, I should keep going. The next one is materialized views. What are materialized views?
What I got is it's a database object that contains the result of a query.
Okay. Somebody has anything else?
Also, it commonly creates primary key, rows ID, object, and subquery.
Okay. Okay, so we're going to go with your definition. We're going to go with your definition. Can you say that again, please?
I said the materialized view is a database object that contains the result of a query.
Mm-hmm.
It's commonly creates primary key, row ID, object, and subquery.
Okay. Thank you. So the next one is partition. The next one is partition. Partition. So what is partition? According to me, partition simply allows a table an index to be subdivided into smaller pieces. Like as the word itself says, partition. It simply allows a table or an index to be subdivided into smaller pieces. And I think there are some types of partition, which I don't know everything, but I know there's hash partition and there's range partition and
List partition and composite partitions.
List and composite partition. Okay. The next one is SQL.
Hold on, Renata. Can you go over the different partition again, please?
Hash partition, range partition, list partition, and Bibish?
Composite partitions.
Composite partition.
So a partition is like you have a database inside of that database you have a schema called Scott an example, and inside of that Scott you have an object called EMP as a big table. So you have those partitions, like in the type of partitions. We do have 4.
Okay. Thank you, Bibish. So the last, before the last one, SQL tuning advisor. SQL tuning advisor. What is SQL tuning advisor? It simply analyzes a single SQL statement and makes recommendations to improve its performance. SQL tuning advisors analyzes a single SQL statement and makes recommendations to improve its performance. So you can relate SQL tuning advisor with application tuning.
So what I got is, another thing to add with what you just said is the SQL tuning advisor also provide recommendation such as rewriting the statement, changing the instance configuration.
Okay.
Or adding indexes.
Recommendation. Okay.
Okay.
Ronaldo, I don't know if you got my question.
No, I did not get your question. Can you say that again?
Yeah, I said when you were talking about partitions, you mentioned the types of partition, but in what category are the primary, extended, and the logical?
Excuse me?
because I know when they said there are 3 types of partition, they said there are the primary partitions, the extended partitions, and the logical drives. So are those considered the types of partitions too, or what? Because sometimes it can be so confusing.
No, I think you're looking at partition from, not from a database perspective. You're
But in
looking at
Oracle, right?
in Oracle, you're talking about range partitions and hash partitions and so on.
Okay.
Mhm.
Okay.
Oracle database partitions, but this is what you're talking about, because you can partition drives.
Yes.
There are many things we can partition. So that's why in the context, that's what I was trying to look at. Composite partitions, are different kinds.
Thank you.
Okay. Last but not the least, SQL Access Advisor. Anybody has an idea of what SQL Access Advisor is? Okay, so
Can I try another? What I got is this advisor analyzes all SQL statement that are issued in a given period and suggests the creation of additional indexes.
okay, you're right. So the SQL Access Advisor simply helps you to achieve your performance goals by recommending proper set of materialized views, the view logs, and the partitions too. Prof, I don't know if I'm right.
So again,
I said the SQL Access Advisor helps you to achieve your performance goals by recommending you proper sets of materialized views, the view logs.
that is just one aspect of it. It depends on what your fix is. You can even the fact that it recommends you to access your data from an index means that it has advised you that the access partition, the access advisor, how do you get your data? You get it from a materialized view, that works too. Am I making any sense? So it's just part of it. But I won't say that is what it is. Are we following? Are you following? Just an aspect of it, an example of it. Okay, the way I want us to go about this is that, I mean, unfortunately, very few people are participating. And I'll prefer that, you know, many people do participate, because whatever it is, this is what I mean. We need to make sure that we know this thing. I want to give a small summary of chapters 12 and 13 so that we can bring down all what both the assignments. I've just thrown out a lot of words. All right. So we'll see how it goes. But the bottom line here is that I don't want you to start performance tuning next week and you are not very conversant with the words that are used, because they might just be using it in passing. And that's why I said, if you go review 12 and 13, then we can come and have a discussion about it, and then we'll see how we can move forward. What I did this morning was that I just went through some of what we did to bring back your mind, your brain, to see how much we are going. But I know that for some people, or I was saying, because what I want to do is, this is basically an interactive session where I want to ask questions about this. Do you remember this? Do you remember this? Do you remember this? What do you think is this? What you don't remember, I can, you know, we can talk about it. And then it gives you a little summary. So you start the class next week, they're throwing words out there, you're not lost. But the bottom line is that we should understand the top to bottom approach. We must understand this top to bottom approach, where we look at the network. So we must, every aspect of our performance tuning will be something about the network, the servers, the database, your instance, and your application. tuning should be pushed throughout all of these, one or of the other. So when you are thinking of tuning, you are always thinking, what are we doing now? What are we doing now? I'm increasing the size of the buffer cache after a cache miss or after the hit ratio is low. Where does that lie? What part of tuning are we seeing that? I'm creating a partition. I'm partitioning a table. What drove me there? What's driving me there? What aspect of the database am I tuning? All right. So we want to talk about optimizer statistics, AWR. Statistics. We know what are statistics. We've talked about it, or I've asked you. When you go to database maintenance is one of the key chapters in this in DB1 because all the moving parts start interacting with each other. A SQL will come from here, from outside the database to get in the database. When it gets there, what happens? How do we enable security in there? What is the use of parsing? How do we enable, where does the optimizer come into play? When is the most efficient path, determined? And how is it executed? We know what we mean by proactive database maintenance. We know what we mean by reactive database maintenance. If something is already gotten bad and you are reacting to it. Proactive, all right? Proactive, you want to fix it before it breaks or anticipate an issue, address it. So there is an automatic infrastructure, all right? That tries to, even while you are sleeping, when you are not there, it is going to try to be fixing its own self. And how is it going to do that? Is it going to try to be collecting statistics? Statistics, you should not be collecting statistics or be part of your job. Statistics will be collected, you being there or not. What do we use our statistics for? Collect statistics, we must use the statistics. There are two kinds of statistics that we've seen, optimizer statistics and database statistics. Collect optimizer statistics once a day. Collect database statistics every hour. If you collect statistics from now till tomorrow and do nothing about it, then it's useless. You better don't be collecting it. But if you collect statistics, you must use those statistics for what? For diagnosis. So statistics must be used. Does that make sense?
Yes, sir.
Yes, sir.
All right. So when we take the statistics, keep them in the data dictionary for the optimizer statistics and the AWR for the database statistics. And the optimizer statistics, keep them in the data dictionary. Okay. So when we keep the statistics in the automatic workload repository, we know that these are what? Database statistics. The AWR has two sections, namely what and what? The AWR statistics are stored where? Or our AWR is constituted of
Memory and disk.
Memory and disk, all right? Where is it kept on disk? What table space?
6 table space.
6 table space, very good. All right, so gathering these statistics that we're going to keep in memory and disk, it is an automatic way, it's an efficient way to manage our automatic diagnostics. All right?
Mm-hmm.
There's a lot of times where you said memory sizes will be changing, even though you have not done anything. Why is it changing? It's changing because it's tuning itself. It's self-tuning. It has self-tuning capabilities, right? And why is it tuning itself? Because based on the statistics that it is getting, the constant should be the constant. Am I sharing already? No. Maybe I did not share. All right. So the automatic workload repository is an efficient way of storing your automatic diagnostic information. Every hour, you collect database statistics. And every hour, we are going to have we're going to have diagnostics on those statistics. So it's that delta value. So we said if your temperature is going up, it goes up, it goes up, it goes up, it goes up. Then what do? You know that it's getting to from the normal is 91, 97. Next hour 98, next hour 99. You're not going to let it go up. You start to see how you can turn that curve, how you can use those statistics to diagnose that it is going, it's deviating from the normal. Then you look for a way to do what? To bring it down. All right. We have this thing called proactive. This word here, proactive, it's a big word. Proactive. What is it? Trying to get something fixed before it becomes a problem. Proactive database maintenance is made easy by a sophisticated infrastructure of the Oracle database, including the automatic workload repository. We have described it as a built-in repository, which has what? 2 sections. At regular intervals, the Oracle database will take a snapshot of these statistics and workload information, and it will store this data in their AWR. Okay? Every how often? At regular intervals, we set every hour. All right? It takes a snapshot. The captured data can be analyzed by you, by the database, or by both. Recommendation is that both. All right? We have all of this data. It's not just for you alone. Data can be analyzed by you and can be analyzed by the database. So tuning is both ways. You must be tuning as much as the database is tuning as well. We use the automated tasks. All right? The database performs routine maintenance operations, such as backups, refreshing optimizer statistics, and doing database health checkers. So the database itself is also monitoring itself. All right? And making adjustments. If you put your, so I heard you talking about automatic memory management and about automatic shared memory management. Those things are there to monitor the database. The database is going, deviating from the normal, it brings it back. Even without asking you, but it knows that this hit ratio should be above 90%. All right. Sometimes we have also what we call reactive database maintenance. What does that mean? There are times that things are going to break and you fix it. All right. There's no way we can fight that one. The database breaks, we fix it. Or our errors, we fix it. All right. Who can give me an example of proactive maintenance? Proactive, something that you can try to do. I just mentioned automatic shared memory management, right?
Yes.
Yes, so that's an example. Okay.
Mm-hmm.
Who can give me an example of reactive? Any error that you get. All right.
Like snapshot to old.
Yeah, exactly. Those are alerts, you know, which the error will occur, it happens, then you go ahead and adjust your database. But definitely, that definitely is one of them. Reactive database maintenance includes critical errors and conditions of checkers. The problems that cannot be resolved automatically and require your administrator to be notified, such as if you run out of space, you need to come and add data. Bam. The Oracle database server provides certain alerts. That's what we're talking about. Provides server-generated alerts. The Oracle database server by default monitors itself and sends out alerts to notify you of problems. The alerts notify you and often also provide a recommendation on how to report these problems. All right? So some of them, like I said, if you go and fix the impending issue, the alert goes away. Some of them, you have to come and fix it and update your alert history. So we have a bunch of advisors which we're going to see. So I want you to look at this framework in three major categories. Maintenance. You have statistics gathering. You have statistics diagnosing, or using the statistics to diagnose. And the third phase, using the diagnosis to advise. 1, statistics gathering. 2, analyzing statistics to diagnose. 3, using the diagnosis to advise. Does that make sense?
Yes, sir.
All right. So we've talked about alerts. We just talked about alerts. Some alerts, you are going to set it up. Like what? Like threshold-based alerts. So what's an alert? There is like a certain violation of the threshold. What's the threshold? A certain number that you put out there. 75%, 85%, based on what your company needs, based on what your service level agreement. Are we good?
Yes, sir.
All right. We also have stateless, right? Or metric-based alerts, like what? Snapshot to all. Someone just said that, right?
Yes, sir.
Exactly. So those kind of alerts, you can have them, but it is not metric-based. You did not set any threshold, but it will occur. Why is it important to have the alert history? If you go to a new environment, is it important to go through your alert history?
Yes, sir.
Yes, to see what has been going on in that environment. Because guess what? It's what is likely to be repeating itself. Are we good?
Yes, sir.
It is what is likely to repeat itself. So we are at some point going to be receiving the same alert. So to play wise, better just go through and look at it. Figure out how to fix those alerts. All right? If possible, you fix it before they break. Because that's the bottom line. That's why we have the alerts. So your alert history page displays a chart that shows the alert history of the current database, segments of time that you are going to designate. An alert indicates a potential problem. All right? So it's not that the problem has occurred, but there's potential for that problem occurring. It could be either a warning or a critical threshold for a certain monitored metric. Or it's an indication that maybe a target is no longer available. Maybe a listener has gone down. All right? I wanted to alert you. It is going to alert you. Like check the alert history and you see different types of alerts that you have been having. All right. Some of the information that we should be very familiar with is automatic workload repository. Who wants to talk about automatic workload repository in a few minutes? Who wants to take a minute and just tell us? AWR, what is AWR? Again, I just like things to be given point 1, point 2, point 3, point 4. What's AWR? Let's do quickly.
AWR is a built-in repository in every Oracle database that collects and maintains statistics for problem detection.
Okay, that gives me like a definition. I prefer a description, like what I asked you to do. Who else wants to try? What is the AWR? I had to talk about it before.
I can try.
Absolutely, go ahead.
Is a state of the database to see when the database is slow, so it can solve and the report every 60 minutes in like an hour. So it can keep the information for 8 days. And the RWR is found on 6 table space, and it fix any issue. To detect issue, like a report.
The initial definition is not right. The initial definition, it is a repository. You are telling us that it is a tool that diagnoses. No. It's a repository that stores statistics, and these statistics are used every hour for diagnosis.
Mm-hmm.
All right?
Okay.
Mm-hmm. What else? Statistics in the AWR are stored, right? We said,
It
collected
is
every
stored in
hour.
the sys tables.
Stable space.
It is stored in both memory and on disk, your sys stable space. All right?
Yeah.
And what else? The in-memory statistics are copied from memory to the disk by the by what?
By M1.
M1. Okay. That's what I wanted. AWR, give me 4 sentences, give me 5 sentences. Okay.
You take a snapshot for every movement too.
Huh?
You take a snapshot for every movement.
For every movement,
Yeah.
what does that mean?
You report everything like every 60 minutes. You snap.
Snap what? Not everything.
The report.
We're having a problem here with trying to understand. When I say, what does it take? The report? No, the report comes after you have collected the statistics. The report is just running something to give you a report on what you've already collected. AWR collects in-memory statistics, some in-memory that have been specified. And it collects those statistics, stores them, collects it every hour, and stores them in memory. Those statistics are copied every so often by the M1 to files on the sys stable space. They have statistics. Every hour, when we go to ADDM, we'll also see that after those statistics have been collected, they are analyzed against the previous statistic, and the diagnostic result is also kept in the AWR and is also copied into the sys stable space by M1. So it's not a matter of putting the words there. The words must mean what they mean.
So I have a question.
Yes.
Okay. What I understand about the AWR is that it's probably an infrastructure that it's an infrastructure that is found in the Oracle database that analyzes and it analyzes problem and probably provide recommendations for possible solution. So
you are analyzing without gathering.
I said, okay, maybe I missed that part.
But if you cannot analyze it that you don't have. Your analysis is based on what you have collected.
Yeah, it gathering and then analyze and provide possible solution for the data it has gathered.
That is, you are talking when the ADDM has already come there and used those statistics to diagnose, then the advisory framework gives you the solutions. That's what I'm trying to describe you the 3 phases.
Okay.
You must gather the statistics, then you analyze the statistics, then you do diagnostics, and then you do advisory.
So
what is the difference between the statistics in a database? If you are not database statistics and optimizer statistics, those are the 2 that I want you to know, separate the 2. Yes, ask the question again.
So my question is because it shows that after the data has been gathered, a possible solution is being being provided or is being recommended for the statistic that it has been gathered. So the question is it being done automatically or is done by the DBA?
Look at this word. What does this word say? Can you see my screen?
Yeah, automatic.
Thank you. How many days have you gone to gather statistics in the AWR? 0. But can you run an AWR report now? Yes, because the statistics are being automatically gathered.
Mm-hmm.
It's an automatic framework.
Okay.
For gathering statistics, analyzing those statistics, diagnosing those statistics, and advising. And sometimes even implementing the advice. They don't ask you. For example, if you're on AMM and ASMM, does it ask you to resize the memory structures? No.
No.
It has the automatic framework where it can automatically tune the database. All right. Any questions on the AWR infrastructure? All right. What's the AWR baseline?
Okay, Prof, I have a question before I can answer the
Sure.
question. So is that like AWR baseline and SQL baseline are two different things?
Yes. One says AWR before it says baseline. The other one says SQL before it says baseline. Different.
Okay.
We'll see it in the next few minutes. What is the AWR baseline?
I say it's a benchmark on which other AWR snapshots are compared.
It's a what?
A benchmark with which other AWR snapshots are compared.
Yes, it is used as a base benchmark, but what is it? That's the use.
Okay.
Yes. Yes, try.
Okay. It's a set of AWR snapshot.
It's a what?
The set of AWR snapshot.
I'm not getting that word. It's a
Set.
Set.
Oh, a set. Okay, good. Yes. A set of AWR snapshots.
That will be used for performance comparison.
Why is that set unique? Why do you decide to go and get that set as opposed to another set? A set of AWR snapshots, which represents what?
It's a threshold.
No.
It shows the different phases of the database.
What? Different phases of database?
No, like let me say like like at various time intervals.
At what intervals?
Let me say like at various time intervals, probably like after an hour.
Various times of database. No. What is unique about that baseline, about that set of snapshots that you have collected? It is a time that represents a very good period or a very bad period or something that you decide that at this point my database was horrible, or at this time my database was running excellently well. And I want to collect the set of snapshots for that time. You're going to come to work and you'll have no ticket. And you'll say, whoa, what happened to the HR? I normally come and see 5, 6 tickets. Nothing is there. Perfect. Everything is running very well. Nobody is going to call you. You can keep that as a baseline. What are you keeping? You are keeping statistics from 10 to 2. From 10 to 2, you look at your hit ratio, 100%. You look at the pass count, very, very low. And you can keep that and say, that's my baseline. So I can use it for comparison. Then come in tomorrow, next week, someday. The thing is going slow like crazy. I can compare what is happening now, which is my baseline with what is happening now, or my baseline with another baseline. I know the numbers for when it works well. These are the numbers, these are the statistics. It's not working well. Can I compare those two numbers and see what is off? Does that make sense?
Yes, sir.
Right. So you take it so that you can compare. But look at the specific time when you have excellent response. All right, what is a metric? A metric is the rate of change of a cumulative statistic. What is a metric? Hit ratio. All right, it changes. What's the metric? Hard pass count. What's the metric? All right, hash hits. Then what are the statistics? The statistics are collected for the metrics. They are data collections providing database and object details for each of the matrices that we have defined. We have optimizer statistics used by the query optimizer, and we also have the database statistics that's used for performance. We set a threshold. When you set that threshold, it's a boundary. We've done that before. We set our threshold to 75%. And when it got to a certain point, what do we expect? We expected it to send us an alert. Are we good? So, the automatic workload repository provides services to internal Oracle server components. All right? Because of this statistics, problem detection and self-tuning purposes. Self-tuning purposes. What is the active session history? Active session history.
It is the history of the activities that happens for a specific session.
For a specific what?
Session.
Session. I'm not going to go session wide. Active session history. People talk.
It's the history of recent session activity.
It's activity. Okay, let me give you an example. Something now is 7:30. You are working. Something happened at 4 o'clock. How are you going to know what to do? The time is already passed. Whatever was hung is already finished. But you can go back in time and see how the database was behaving at that time. Does that make sense? So it's not for a particular session, it's for a particular time period. Are we good?
Yes, sir.
Yes, so we look for a particular time period. All right. See my active session history here. I can run an ASH report. It's 7:30. Let's see. It says 7:03. Something happened. I don't know what happened here. You see my cursor, right? I can take this guy and put them here. Right? You see, for that 5-minute interval, from 7:59 to 7:04, tell me what happened. This is what happened during that time. Are you following? So that person said, you ran this query. I said, what time did you run it? He said, I ran it at 7. What's the time now? 7:30. But we can go to the past and see what happened during that time. Are you seeing the sequence that was fighting here at that time?
I have a question. So is this for one, Prof, I have a question.
Yes.
So is this for one specific session or is it for multiple sessions?
For every session that ran, within that 5-minute interval, these are what happened. And an insert happened, a select happened. There was a PL/SQL executing, an update occurred. There were 3 selects here, an update and that and that. These are the different SQLs that happened within this 5-minute interval.
Okay, from different sessions, okay.
Could be for one session.
Okay.
But within that period, that's what happened. But I'm looking for active session history for everybody. So now my job becomes, let me start isolating to see what particularly, who was doing what was doing what. You see what I mean? Yes. And then we can You know, look at the different users who are doing the different things are there. The top sessions. So if yours is hanging in there, like once, okay, you were the one who was causing this is what, and so on. But look at it, it has how many sessions like this here? For this 5-minute period that we have here, how many sessions do we have? 5, 25, 1, 31, 1, 26, 25, 1, 22, 24. You see that? 25 again. So this one had 2, right? And sets. So it could be for 1 or it could be for multiple. But we can go back in time. Else, what would be your alternative if you don't have active session history? What would be your alternative?
Probably check alert logs.
No, not that. Sometimes performance issues will not show up in alert log because it did not crash, it was just slow. An alert log will not show you that it was slow. But your statistics that you've gathered will show you that it was slow because it has something to compare with. Alert log will show you that it was not working or it was working, trying to do this, it could not do. You have to ask them to do what they did again, correct? So you can try to capture it. Are we following? Are we?
Yes, sir.
How are you going to get it? You must ask them to do it again. But now you say, just tell me the time you were doing it, I can go and see what actually happened. Because we usually say, could you do it again so that I can monitor and see? And the users hate that. Because a lot of times they'll say, okay, I cannot do it. I cannot just hire anybody. And this is production. Any questions? Any?
Yes, please. If you can just go back, please. So I wanted to know if those SQL statements, right, are they associated with the top set with the sessions? So maybe the insert is that associated with the DB writer? Like, is that how you associate it, or is it like different?
Associate, I don't
like
understand.
the SQL statement, because I see the first part.
This insert SQL statement, correct?
Yeah.
Okay, it said top activity, which is what we got. It was consumed about 25%, right?
Okay.
So we know that it was an insert statement. So what I'm doing here is that I'm going to try to get into that SQL statement, right?
Right.
I'm asking it to show me how it was being executed. We came here the last time, right? This guy has a snapshot of the text.
What you say?
For some reason it's not giving me, it did not give us yesterday, I'm not sure. But you give us the SQL text, right? We saw the other one it gave us. But what we are really interested again here, now we can come to the plan. It's not available, the text is not available, so it's not getting that.
It's supposed to be the
please, what's
introduction to information security. Do that tomorrow. Okay?
Anita, mute Fali.
Actually, Renata, you're the host again.
So I don't know. I went there, but I couldn't see my own graph.
All right, so we saw this SQL here, right? I went to the next one. It showed us the SQL that generated that, correct? Again, sometimes the SQLs are no longer in the buffer, so no longer. Well, what you're interested in now, you're seeing the SQL, right? What it was actually doing. All right, and you can go to the plan, and you can see that's the explain plan of the SQL. These are the parts that it used. The object that it queried, ordered by number of rows, bytes, cost of that SQL, percentage CPU, and so on. So it's giving you the details of the SQL. Does that answer your question, Anita?
Not quite. No, I just wanted to know the association with the, because if you go to the graph, it shows you the top section, and then it shows you like the like at the bottom. Yes. Then on the other side, it shows you the users and then the program. So I wanted to know if these programs are associated with the SQL tag.
What program, like this?
Yeah, so those are the processes, right?
Yes.
Okay.
It says the program is Oracle and student .solutions.com, right? And DB Writer is what was doing that.
Okay.
You know, it was an insert, right?
Yeah.
So DB Writer should be working.
Okay, yeah, so that's why I was asking if they go hand in hand.
Exactly. No, the thing is, it is absolutely the system, you know. Log Writer will write its own thing to it's sometimes this is just, I mean, to clarify, yes, Log Writer is writing, DB Writer is writing. There are processes. Remember, there are 150 of them. We cannot even keep track of them. All right. Every process doing its own job, several processes and so on, doing copying here, cache hits, cache miss, and so on. The beauty of this product, and which I wonder, that's why I wanted you to go install it, is that you start seeing from the back end how you perceive when people have problems up front. All right. And you come behind here and you say, okay, top sessions, top SQL. What is top session? Now you are going per person. You are going for the person. Because let's assume that it is people, sessions, going in there and running queries. Does that make sense? The person who opened the ticket, that's the username you're looking for here, right?
Correct.
Yeah, right.
Yes.
So in other words, when you want to explain like the active session history, like the program is not very, it's not very important, right? Like what you need is like the SQL type.
It is important because I came here because somebody opened a ticket. Does that make sense? That is what drove me here. So I am looking for what is the issue that Mrs. Smith is complaining about.
Analyze the issue.
And I must come in here and my first job is, was Mrs. Smith doing a transaction? Yes, she was doing a transaction to pay somebody. To pay somebody, what does it take? Yes, it takes 25 different SQLs to transfer somebody. Are we good?
Yes.
Which one is my top SQL now matters a lot because I must come and see the top ones is the trouble one. It is taking longer than required or than, sorry, expected. You must be trouble SQL. You must be high load performance. That's why you come in here and you see it says top activity, top sessions. Which users have been consuming the most? And once you identify those users, amongst them, you will see that for that, the top activity will come from those users. You can go only strictly for the top, what is it? The top SQL. But you must identify it because it always comes from exception. All right? Again, look at it. You can see, you have options of what you want to see. But I'm interested in the session because a user is complaining. But the top activity could be activity from different people, different sources. But whichever user is complaining, maybe this update that she was trying to do right here. And that was giving her a tough time. And it could just be locked because something else was there before. You don't fix it. You simply say, could we try to run that at a different time? Or you find out if there's a coincidence where that C2 runs several things. You said no. And sometimes with these tickets, if I see locks, well, I don't see anything obvious, I'm not going to fix anything that's not broken. I will ask you to please specify the exact time that you're doing it. If possible, send me an email. I've had that situation. 5 minutes before you want to run that process. So by the time she's running it, I'm behind here already. Does that make sense?
Yes.
Yes, sir.
Any other question? Statistics are collections of data that provide more details about the database and the objects in it. Optimizer statistics are used by your query optimizer for best execution plan to choose. Best execution plan for each SQL statement, while database statistics provide information on performance monitoring.
So, Professor, so this active session history will be important for instance tuning, right?
For what instance tuning?
Yeah.
Let me ask you this question. Instance tuning. What are these?
Oh, okay. So applications tuning as well.
Yes.
Okay.
More so.
Okay.
Note that when I start going for individuals, it is usually I've already gone into application tuning. But when it was affecting multiple people, right, then the buffer cache is low, it will affect everybody. Can I come here and see what happened during those 5 minutes? Yes. And I can also check what the heap ratio is, or I must have seen it long ago, even before I got here. But when it starts takes me to granularity of seeing what one person was doing, I've already surpassed network, database, instance, and I'm, for the most part, in application tuning already. Because when I say a user is doing something, what does that mean? A user is running a SQL. Are we good? And that SQL be over, so that it is taking memory, too much memory? Yes, it can. And be an overused SQL. Are we good?
Sure.
Yes, sir.
There is no conversation, so I don't even know if you are getting it or not.
Yeah, we hear. You say yes, sir.
Oh. All right. So, AWR snapshots. What are these AWR snapshots? We know they take them every so often and keep them for a certain amount of time. We know that there is something called a baseline, which is a set of AWR snapshots that are collected over a period of time. All right, what will determine your baseline? When the response was really good. And our baselines will be used for a comparison, or with another baseline, or with the current. System moving window. Your database must run for about 8 days before you begin collecting statistics. All right. So if your database is newly created, you just wait for 8 days and you'll start seeing a system moving window. All right, so let's talk optimizer statistics. Optimizer statistics. What are they? How often are they collected? How often are optimizer statistics collected?
Every 1 day.
Every 1 day. Okay. Where are they stored?
Data
They're stored in the data dictionary. All right. So Solar Optimizer will use those statistics to determine what? The most efficient execution plan. All right. And it says it is the most important step, right, in the running of every SQL statement. Because if you don't, Optimizer does not choose the best step, the best plan, your system will be slow. That's the bottom line. And for optimizer to do that, it must need statistics about that table. For example, the number of rows, because like I told you the last time, to search 1,000 rows or 10,000 rows is very different from 100,000 rows or 1,000,000 rows. Same query that you are running. At some point, the query is no longer efficient. Why is the query no longer efficient? Because data has grown. Is it a bad thing? No. It's a good thing for data to grow. Are we following?
Yes, yes.
But at this point, that query no longer satisfies your need. So what do you need to do? You need to change the execution plan. It evaluates expressions and conditions. It uses object and system statistics. It decides how to access the data and decides how to join tables, and eventually determine the most efficient execution plan. All right? So, Optimizer is a part of the Oracle database that creates the execution plan for a SQL statement. The determination of the execution plan is an important step in the processing of a SQL statement and will greatly affect execution time. The execution plan is a series of operations that are performed in sequence. You know, with a computer, we want to make the sequence. It will occur, but in what sequence does it occur? The optimizer considers many factors before it decides the most efficient plan. All right? The information necessary for the optimizer statistics for the optimizer will include statistics that are gathered for I/O of a system, a server. These things do not change very often. System statistics. All right? The I/O, the CPU, it came, and that's what it is, and it is sitting there. As well as schema objects, number of rows in a table, and we have indexes on that table. We also need information in the data dictionary, which is what? The statistics that are collected in the data dictionary. They are needed. The where clauses. We also need to give optimizer hints that are supplied by the developer. What are hints? Database hints. What is a database hint? What is a hint? A hint.
Is to force that optimizer to recognize the part of the SQL?
Not actually force it, but you can advise it to use an alternative strategy from what the optimizer is trying to use. The developer wrote the SQL, right? The developer had transcribed different things. He knows the one that's going to work best. But when the developer was trying, he knows that optimizer was trying to use this. He suggested this. Optimizer is always trying to use cost, he used rule, and it worked better. So you can help the optimizer by giving it a hint. You create an index on the table, and the optimizer is like, there are 8 indexes here. You can see, don't think. Just use that index because it was created specifically for this query. And your query executes very well. Does that make sense?
Yes, sir.
Yes.
Okay, so when you diagnose tools, use diagnosis tools as a plan. SQL auto trace, you can see your execution plans. Okay.
Question.
Yes.
Okay. So I just wanted to know, does the system or Oracle have a way of determining which tables are going to be created with indexes? And also, how does this, do optimizer statistics affect this decision to create tables with indexes?
No, you are not creating a table with an index. Let me give you a story of an index or how we come about an index. Let's say you have a table, that table has 1,000 rows. You're querying it every day. You're getting your query in less than 2 nanoseconds. You're fine, correct? But due to time, the table starts growing. Data and that table starts increasing. I don't care, that table has 25 columns. You don't need an index at that point. 1,000 rows, you don't need an index. 10,000 rows, you don't need an index. Does that make sense?
Yeah.
Because the number of rows is small enough that even if I query the entire table, I don't need any pointers. If I do a full table scan, it's still giving me that. Why? Because the data is small. That's the bottom line. But what we're saying is, what happens when the data starts growing? Now it's 100,000 rows. Now to scan all of the 100,000 rows is taking a significant amount of time. Maybe you want to create an index at that point. Does that make sense?
Yeah. It does.
Yeah. So it's just due to data growth. Now you need pointers because it is being detrimental to your querying the entire table. It's no longer a small table. It's a big table. And what do you have to do? Create an index to point to those columns that have the data that you need.
Okay.
So that is why there's something called tuning. You don't just make the product and throw it out there and say go. Depending on every environment, how they use the data and how they use the database, they have different tuning opportunities. You sell the same product to two people. They use it every day. One person's data is growing, the other person's data is not growing. They are in different businesses. You cannot tune the two of them the same.
Okay.
But tuning is something that needs you to, or that is required every environment.
Okay, so tables indexes that are automatically created, is there is there a guideline? So is there, like, let's say if a table is created with maybe a certain number of rows, then will Oracle know that it needs to create an index then?
Will a table be created with rows, or you will be adding rows as it goes ahead? The table is created with columns, right?
With columns, yeah. Well,
But the index does not depend on the column. The index depends on the number of rows. It's once you have bought the product, you brought it, you took it home. But due to your business, the rows are growing.
okay.
You're not convinced.
Hmm?
You're not convinced.
I am, no, I seriously, I just want, I am convinced.
Because it is your usage of the data that has increased the number of rows. So your table demand starts becoming different. Even the manufacturer will not know until we go and start looking at their statistics. Ah, this is what you have. Oh, okay, wow, okay. You see, but company B is not using data as you are using. For them, that table is still very, very fine or very small, or they are not as aggressive in doing business. Does that make sense?
Yeah.
So a database tuning, performance tuning, is not something that can be manufactured in the shop. It is something that you have to be in the environment and you talk it. And why is it very nice to talk? Because there are no two environments that have the same tuning mindset. But when the interviewer is interviewing you, he wants to see your analysis. He wants to hear you talk about creating an index because you realize that from the explained plan, this table was doing a full table scan. You don't just say it's slow that you created an index. No. Does that make sense? Because of the statistics that you analyzed. You found out that you saw in the explained plan that there was no index here, but it was querying about 100,000 rows. So now it occurs to me that how can I fix this? I can create an index to fasten that query. But that may not be the fix for the next person, because the next person, in fact, what kind of index are you going to create? Now it depends on the kind of data that they have. And that's why I'm trying to explain what performance tuning is. Such that, because if we come in here and whatever they were querying is in HR, right? And let's say it is the HCM, the Human Capital Management table, the employees table. What is unique about the employees? What kind of data is unique about employees? Somebody tell me, please.
Names.
What kind of data will be unique about employees? That's what I would working on the EMP table.
Employee ID.
Employee ID, perfect. Because it is unique. Right? There are no two employees with the same employee ID. So because it is unique, now what kind of index will be created in an environment where you have unique indexes? Or you have unique keys. You have to create what? A B3 index. What about if this was in CarMax? What is this about cars in CarMax? Yes, they have 20 million cars. Data has grown as well. What kind of index will be good for CarMax? There is no unique car. Does that make sense?
Yes, sir.
Toyota can either be a Corolla, a Camry, or this, or this, or that. An Altima will also, a Nissan will be an Altima Maxima, or this, or this, or that. So there are numerous, there are no unique keys. There's a low cardinality index is needed in this case. I'm not going deep into it, but I'm just telling you that they are unique. They are different. In that case, I'm going to create a bitmap index because they are better suited to handle low cardinality data. Hello?
Yes, sir.
Are we following?
Yes, sir.
Yes, sir.
Good. So that is why I wanted to do not look at performance tuning as if, where is it? This is it. Where is that? No, it is how your data is morphing out. It's how your data is migrating or is emerging to be that we are going to be using different methods. Performance tuning can be very, very easy if you can take the time to just sit down and absorb what we're doing now. So look, for example, we want to collect optimizer statistics so that our optimizer can use to determine this execution plan. Select star from HR.employees. See what it gives you. This is directly from the table, right?
Yes.
What is the count?
214.
214. Now we select from data dictionary, right? This is data dictionary, correct?
Mm-hmm.
So we're getting it from the statistics that was collected, right?
Yes.
Yeah.
Look at the counts. 107. So what does that mean? Between this one and this one, the number, okay, between this is what they got in the night, right?
Mm-hmm.
When they collected the statistics, 107, right?
Yeah.
This is what is going on now, which means the number has doubled. But if optimizer is still using this 107, guess what? It is what? A statistically incorrect number. Question, let me start first. When you collect statistics in the night, right?
Yeah.
And it is, let me give you my example. You have 1,000 rows. You collect statistics in the night is 1,000 rows. You hire 10 new people, it becomes 1,010. If you run a query at 12 midday, will you use 1,000 that you collected in the night or 1,010 after the people have been hired? What will you use? What will optimizer use?
1,000.
Before
use
1,000.
1,000.
All right.
1,000.
Okay, I understand. So it's going to use 1,000 because it is a number that it collected in the night.
Yeah.
All right. But if that number is greater than 10%, we consider the statistics to be what?
Yeah.
To be what?
Still.
Stale.
To be stale. All right. And it is no longer a good representation of the data in the database. In this case, it doubled. So guess what? Optimizer will be using the stale 107 when the table column is what? 214 already. It has doubled in size. We're not going to be having good queries. Does that make sense?
Yes, sir.
All right. So optimizer statistics include The table, column, index, etc., etc. Statistics for tables, indexes are stored in a data dictionary. These statistics are not intended to provide real time. Does that make sense? It does not provide, right? Not intended to provide real time. Are we following? If we have to calculate this statistic before we run it, it will take too much time. The database will run too slowly. So it is not intended for real time. It's intended for what? A statistically correct number, correct?
Mm-hmm.
All right. So they provide what is called a statistically correct snapshot of data storage and distribution, which your optimizer will use to make decisions on how to access data throughout the day until the next time we collect the statistics. We good? Are we good?
Yes, sir.
Yes, sir.
Can we manually collect statistics?
Yes.
Yes. If our statistics are stale, it has an opportunity for us to manually collect the statistics. So statistics that are collected will include the size of the table, the number of rows, average row size, and chain height, etc. So it says here, as data is being inserted, deleted, and modified, these statistics will be changing, right? The facts will change, the number of rows will have changed. But there will be a performance hit if we try to calculate the statistics before we run on real time. So real time is not an option because of what? Of performance, all right? It is prohibited. These statistics are updated periodically, gathering statistics on tables and indexes. Optimizer statistics are collected automatically by an automatic maintenance job that runs during the predefined maintenance window. Once daily by default, we know that it runs every night and so on. Optimizer statistics are not the same as database statistics. All right, so if we had a situation like this one, where our statistics has changed, we can manually go and gather statistics, correct? So you can bring up this wizard, we've seen this before, right? Look at the notes. See, manage optimizer statistics, you can click on that and you're telling that you can do what? You can gather statistics, you can restore statistics if you backed it up. You can actually lock statistics. If you lock it, you can unlock statistics. Or sometimes you can just delete the statistics. I've been in a situation where we had a lot of issues and the solution was just delete all the statistics and regather them again and run as smooth as a charm. To manage optimizer statistics in Enterprise Manager, you're going to go on that server tab and so on. You click on the gather statistics, like I said. You can restore it if you backed it up somewhere to a point in time in the past. The chosen point in time must be within the optimizer statistics retention period, which is like 30 days. You can lock optimizer statistics to guarantee that the statistics for certain objects will never be overwritten. That's useful if statistics have been calculated from certain table at a time when well-represented data is present. And you want to always have those statistics. No fluctuations in the table affect the statistics if they are locked. You can also unlock optimizer statistics and you can delete optimizer statistics. When you are setting up your statistics, please leave your statistics level to what? Typical. Are we good? If you put it at all, it's going to overgather statistics. If you put it at basic, it is going to lose all your ADDM functionality, all your automatic diagnostic functionality, which we do not want. Are we good?
Yes, sir.
So,
all right. So when we come in here now, we can select the scope with which we want to gather the optimizer statistics. You can gather it at the database level,
Table.
schema level, table level, etc., etc. All right. So you select what you want to gather the statistics for. All right. So everything you do in Enterprise Manager, you always have a DBMS job that can do it, which is your DBMS stats packages. You can have your DBMS stats, DBMS gather schema statistics, database statistics, or sorry, table database statistics, tables schema statistics, or table statistics in that order. All right. These are the, if you want to manually do it, your jobs are already there. That will help you gather at every level. Start here meaning what? At database, schema, or table level, gathering the statistics. All right. So you see this guy here now, it says, if before you run that command, you do this, execute gather statistics for that table, HR.employees, when they did a query now, what would they have? Select number of rows, even though they selected this time again from the data dictionary, but it was just analyzed, and guess what? You can have the true count of the table. After here, it had doubled the number. Are we good? Are we?
Yes, sir.
Yes, sir.
I'm teaching when you are tired. Notice that the number of rows now correctly reflect what was in the table at the time that statistics were gathered. All right, DBMS stats also enables manual collection of statistics for an entire schema, or you can collect it for an entire database, no problem. Operating system statistics, otherwise we call it what? System statistics. They do not change unless the workload significantly changes. As a result, system statistics do not need to be frequently adjustments. All right. DBMS stats gather system stats. Will collect those statistics over a certain period, but it's not something that changes. Your processor, your machine is there with the number of processors that it came with, and it's not going to be changing that quick. All right, all right, all right. Preferences. When you are gathering statistics, you can also specify preferences. So what are these preferences? You saw something like your stale percentage, correct?
Correct.
Yes. It's defaulted to what? To 10. But you can change it like they did here. Right? For that query, they said stale percent, change it to 13%. All right? You can also, other statistics, when you're gathering statistics, you can also set preferences like what? Cascade. Cascade simply means if you are gathering for the table, let it affect all the other objects that are dependent on that table. Let the gather of the statistics be cascaded onto those dependents, like indexes. Degree of parallelism. You can gather for a certain part of the table and extrapolate, right? 50% you multiply by 2, 25% you multiply by 4, and so on and so forth. All right, what else should come here is what? Publish. Once you manually gather your statistics, you can decide to publish your statistics immediately to the data dictionary, or you can keep it in a holding area, after which you're going to publish. And of course, 0%. So preferences for gathering statistics, these preferences can be at the database level, which means if you set preference at the database level, it iterates everything from the schema to the table. If you set it at the schema, it just covers everything on the objects in that schema. If you set it at the table, that's the statistics that we gather. So if you want it for a specific table, do it for that table. Because if you do it at the schema level, it will affect every table in that thing. All right? So that's the bottom line this one said. So it says set table or schema or that. All right. So here we're just talking about iterating. If you set it at the global, overrides everything. Set it at the database statistics, that one will cover everything for that database. Every table or every object that you're getting statistics for. It's just rules that you're going to use. As we said, the rules are what? Parallelism, cascade. All right, cascade to the other objects in the indexes. Degree of parallelism. We know that one by now, right? We're doing parallelism all through backups, correct? Hello?
Yes, sir.
Probably 10%, etc. And estimate percent. Those are ones I want you to think about or think of. You guys sound like you're tired. Are you?
No, sir.
No, sir, we're here.
You're here. All right. What I want us to do is I want you to actually go and it's a good thing that you guys try to answer the questions at the beginning of the class, but those answers were, how will I put it, they were too scanty. I want you to give me give me a good paragraph or less, if it is less. Not all of them have the same. Some definitely have more of each of those words. But if we wrap up this thing, I will go through those words on Friday. Then I'm sure you are good to start that class next week.
Can you say it one more
Does
time,
that sound
please?
like a plan?
Yes, sir.
Yes, no, maybe?
Yes.
Yeah.
All right. So let me see you back in about 15 minutes. Then let's talk on automatic workload repository and see what we can wrap it up. Yeah, 15 minutes, 10 minutes even.
Okay.
15 minutes.
Okay.
Let's come back and wrap this thing up. I'll try to wrap up by 9 o'clock.
Patrick. Hey, Patrick.
Hey, Anita.
Yeah.
Hi, Marie. Hi, Patrick.
Hey, Anita.
How are you?
Good, good. And you?
Fine. Please, can you upload this to Dropbox?
Yeah, sure. I will.
Thank you. Thank you so much.
No problem.
Where's 12? I think it's time.
All right. The automatic workflow repository, are we there?
Yeah, Prof.
Yes, sir.
All right, so we say it is an in-memory section. All right, in-memory section, and also file, right, permanent storage section. Why do we have it in memory? Why do we have part of AWR in memory?
For easy access.
Absolutely. Memory, we know it comes with quick access, correct? Why do we have it on disk as well?
Case of crash.
To survive in case of crash.
Absolutely. Our instances, as we know, they can crash. And also we want to keep historical data. We want to keep a lot of it so that we can be doing 4 days, 5 days, 10 days. And for us to do that, we will have to we have to store them in permanent storage. In what table space is that permanent storage?
6-ox table space.
6-ox table space. Very good. So built-in repository for performance information, snapshots of database metrics, which are taken every 60 minutes, retained for 8 days. We know that we cannot choose. We can change all of these, right? Are we good?
Yes, sir.
Yes, sir.
But all we say is that consider storage needs before you change them. All right, automatic workload repository is the infrastructure that provides services to the Oracle database 11G components to collect, maintain, and utilize statistics for problem detection and self-tuning purposes. You can view it as a data warehouse of database statistics, metrics, etc. Every 60 minutes by default, the database automatically captures statistics information from the SGA and it stores it in the AWR in the form of snapshots. These snapshots are stored on the disk by a background process called MON. By default, snapshots are retained for 8 days. You can modify the snapshot interval and also the retention interval. AWR contains hundreds of tables, all belonging to the sysman schema and stored in the sysops tables. So I can query that. You'll see hundreds of tables in the sysman schema. And we'll see, we can query the table space as well. I had a query here. I think I've closed it. All right. Oracle recommends that the repository be accessed only through Enterprise Manager or the DBMS workload repository package. Do not write direct DML. SQL on those is not allowed. So you can access it only through Enterprise Manager or through your DBMS package on SQL. All right. We have our in-memory section and also our snapshots on the files. These are responsible for what? Self-tuning capabilities of the Oracle database. Depends on our information, our statistics. It has 2 major parts. In-memory statistics collection facility. All right. To collect statistics. Statistics are stored in memory for performance reasons. All right. When things are in memory, we get them faster. Statistics stored in memory are accessible through our VDOLA views. Snapshots that present the persistent portion. Persistent portion is what? The files. Snapshots are accessible through data dictionary views. Why do we have them in the statistics stored in files? Statistics, they need to survive instance crash. Some analysis also need historical data. Like for baseline, we talk about our baseline comparisons, right? We want them to be old enough. Also, we may have what we call memory overflow. Memory overflow can occur when old statistics are replaced by new ones because of memory shortage. The replaced data can be stored for later use. The memory version of the statistics is transferred to disk on a regular basis by MMON, the background process. With the AWR, the Oracle database provides a way to capture historical statistics data automatically without DBA intervention. So automatic self-tuning, you don't even have to be there working on its own. We talked about the baseline. What is a baseline? A set of AWR snapshots. All right. Why may we may we collect this set and create a baseline? We said it is a well-represented period when statistics or database was performing optimally. So we can use the baseline. Set of AWR snapshot, usually a set of snapshots for an important period that you are going to tag and retain. All right. Set of snapshots, data for an internal period. The baseline is defined as a pair of snapshots. The snapshots are defined by their snap IDs, or a start time and an end time. Each snapshot set has starting and ending snapshots and includes all the snapshots between. So we say from 10 to 2 will be from 10 to 11, 11 to 12, 12 to 1, 1 to 2. So all of those snapshots. Each snapshot set has a starting. Snapshot sets are used to retain snapshot data. Therefore, by default, snapshots belonging to the snapshot sets are retained until the snapshot sets are dropped. An expiration value can be set to a number of days that the snapshot will be retained. The baseline is identified by a user-supplied name. So when you create a baseline, you're going to give it a name. You can say optimal performance or Tuesday's best or whatever it is. And you specify a name of the snapshot. Baseline will have a life of a database is assigned to a newly created baseline. The baseline identifier that is unique for the life of that thing will give it a name, a unique name. Usually you set up baselines from representative periods in the past to be used for comparisons with current system behavior. A well-represented period in time in the past to be used to compare with current system behavior. You can also set up a threshold-based alerts using baseline from database control. You can set the expiration time, the number of days with the expiration parameter of this procedure. The default is null, meaning that our baselines will never expire. So you can go to your snap IDs. You can see your snap IDs by calling your DB history snapshots. All right. Have we seen an AWR report before, correct?
Correct.
Hello?
Yes, sir.
Yeah, we did run a report. You know, that thing is very, very comprehensive. Gets lots and lots and lots of information. But at least I want us to know what that report is. What the AWR is, that infrastructure. So we can select a period of time, a couple of hours, 2-3 hours, and generate an AWR report. So a lot of what you will do in DB2 is you look at that report and see how you can interpret that report. The best way you know how. All right? Edit the workload repository settings. You can look at the detailed information about creating snapshots. You can create baselines, and you can generate AWR reports. All right? So you can decide how you want to keep it for your retention times. Is it 8 days or what? So it says you can go to edit settings and you can change the 8 days, which is our AWR retention time. Collection interval, 60 minutes, you can change it. Also the collection level, all right? Basic, we say, is very discouraged because it disables all the automatic diagnostic functionality. Typically is what is recommended, and if you go for all, you are over collecting statistics, and we know that that's not good. All right, you go for all only when you have a brand new application, you run a full load and you let it go. AWR settings include the retention period, the collection interval, and the collection level. Remember that decreasing any of these settings affects the functionality of components that depend on the AWR, including the advisors. Increasing the settings can provide improved advisor recommendations that are the cost of space that is required to store snapshots and the performance expended in collecting snapshot information. Consider setting to all when you're tuning a brand new application. We all collect SQL execution plans and timing statistics and enhance the recommendations of the SQL. All right? When tuning is complete, you need to change it from the all back to the SQL. So if you are collecting statistics for every SQL, it's going to drag your system down. So what we're saying is the brand new application will test it, run it on also it has at least some baseline value of your SQL. And we'll take it back to typical. I'll turn time statistics and SQL statistics for an individual user, not for the entire database. Because again, one must always balance, make sure that we do not over collect. So when this is the details of collecting at the basic, self-tuning capabilities are disabled. Typical, as was recommended, do it for all, we will be collecting additional statistics for all SQL statements. And we don't want that. Again, I've explained to you what the basic means in terms of self-tuning capabilities. Typical, all the major statistics are collected that are required for your database self-management. They represent what is typically needed to monitor Oracle database behavior. This includes automatic gathering of statistics to reduce likelihood of poorly performing SQL statements due to stale or invalid statistics. When you do all possible statistics are captured. The level of capture adds timed operating system statistics and planned execution statistics. These statistics are not needed in most cases and should not be enabled for best performance. They are sometimes needed for specific diagnostic tests. So if I come into, let me jump in and show you when I may do, let's go here. If you want to turn on statistics for a specific user, I'm going to do something like this. Yeah, what's wrong with this? 1 minute they're working, the next minute they're not working.
The servers are very slow.
Okay. The top consumers. Okay, so if I come in here for my top sessions. All right, so let's look at the top session. The first one here is the DBSNMP session. You see here, enable SQL trace. Do you see that?
Yes, sir.
Yes.
That's how you gather statistics for a specific session. So if you came in here and somebody was running something, let's say this guy, Sysman, you can enable trace right there. And it's going to be gathering all the statistics, so that's 125. Every SQL that you use, so if I've identified person who has that issue, I can look at them and gather more statistics for their run. And it will help me in giving me more details of tuning. All right. I also told you about, if you want to see the tables, go to schema. Oh, what is this now? Hey. The tables, what was that? Okay, the tables that belong to schema. Just query it. Oh, maybe they are working on their databases, or their databases are down. They're practicing how to clone schema. All right, to set some tables owned by Sysman and in the sysox table spaces. Are we following? Your AWR tables. Your AWR tables. Owned by Sysman. In the sysox table spaces, I just want to show you the AWR, a bunch of tables. It's a repository. Okay. Here they are, sysox. They have hundreds of tables, 701 or 710 of them. Sysman schema and the sysox tables. All right. And go on and on and on and on and on and on and on. All right, don't say the last one. ADDM. So what do? We gather statistics so we can use it for what? Diagnosis. Are we good?
Yes, sir.
We gather statistics so we can use it for diagnosis. How soon does AWR run?
Every hour.
Every hour, absolutely. After every gathering of our snapshot, we compare this snapshot that we just gathered with the last value. It's called the delta value. All right. So it runs after each AWR snapshot. It monitors the instance and will detect any trouble, bottlenecks. The results of the ADDM are also stored in the AWR. So our AWR also has ADDM results in there. Again, let's look at it. Gathering of statistics, using those statistics for diagnosis, and after that for advisory. Are we good?
Yes,
Are
sir.
we?
Yes, sir.
All right. So, unlike the other advisors, ADDM runs automatically after every AWR snapshot. Each time a snapshot is taken, the ADDM performs an analysis of the period corresponding to the last two snapshots. ADDM proactively monitors the instance and detects most bottlenecks before they become a significant problem. In many cases, ADDM recommends solutions for detected problems and even quantifies the benefits. I told you about quantifying benefits, right? We said this benefit can give you, it doesn't usually give you one solution. This can give you a 50% improvement. This can give you a 20% improvement. This can give you a 5% improvement. Which of them should you go with? Solution A, B, or C?
Solution A.
20%.
Solution A gives me 50%. Solution B gives me 20%. Solution C gives me 5%. Which should I go with?
Solution A.
Except
it affect the database. Except the database won't be down.
yes. Except it's going to affect database availability. If I have to implement A and get 50%, but it will entail database shutdown, nope, then we'll not do it.
Yeah.
We'll always go with the highest. We can monitor things from CPU bottlenecks, poor Oracle net connection management, lock contention, input-output capacity, undersizing of memory structures, right?
Mm-hmm.
High SQL load statements, high PL/SQL and Java time, high checkpoint load and the cost. Let me show you the let me show you the ADDM. We have to go back to Advisor Central and take a look at ADDM. Okay, performance. Advisor Central. And you see your ADDM runs. Okay, see these ADDMs here?
Mm-hmm.
You see them?
Yeah.
That's every hour. If you look at the time here, it will tell you yeah, the time in days. Every hour you see, it's 9 o'clock, we just ran one now at 9, 8 p.m., August 19, 7. So as we're collecting statistics, we're running diagnosis. Are we following?
Yes, sir.
So you can come in here and see, look at yesterday at 11 o'clock. It took 15 seconds. That may surely be the problem, maybe. Even this one now is taking what, 23 seconds. All right, we can look at the results. So something is happening there. You see what's going there? The throughput, the hard parsing, commits. So this is the ADM analysis for right now. Let's look at let's go back to Advisor Central. Let's look at some time where there was almost nothing going on there. Let's look at this one. Says there's what, 1 second. And you look at the results, tells you that ADM did not find any problems at that time. You see that?
Yes, sir.
Okay. So if we follow that same principle, which one again are we going to see? Let's look at another. This one says 0. Let's try that one. What are we supposed to see there? Nothing, right?
Yep.
ADM did not find anything. All right, let's look also. Another one where there's something. Look at this one from yesterday, 15. You see that?
Yes.
Let's look at the results. We'll see something surely be there. When it takes longer time, what is it? 15, this guy here. Okay, good. You see activities took place, right? IO throughput, 48%. Impact, 48%. Commits, hard passing, undo. So it can give you different issues that took place. All right? Occurrences in the past 24 hours. So ADDM, as you have seen, is a diagnostic tool. All right. You can also look at ADDM from this perspective. This is one report for every hour. You can also click on part of the advisors. It gives us that, and we can look at our different snapshots. Does that make sense?
Yes.
See this one from the last time. If we click on these snapshots here, we're definitely going to see something. But that was the one from the 18th, so that's another interface. Click on that snapshot. We'll say OK. It says, do you want to run another? You say yes. The snapshot is being taken, which automatically result in an ADDM run. So we're forcing an ADDM run to take place at that time. No, this thing is not on our side. Performance. Anyway, let's go up this thing up. Okay, so these are the possible bottlenecks that we may have. CPU, that lock, and so on. So ADM will give us. You see how easy it is to click. If you know where to go, it's a piece of cake. So you look at, they are looking for what? These spikes. See, that's what I was looking for too. Correct? And then you can come here and it's telling you where we're having issues. And you can deal with your ADM findings. So on your automatic database diagnostic monitor page, you will see the detailed findings for the last ADDM run. The database time represents the sum of the non-idle time spent by sessions in the database for the analysis period. Specific impact percentage is given for each finding. The impact represents the time consumed by the corresponding issue compared with the database time for the analysis period. The slide graph shows that the average active users increased dramatically at this point. In addition, the major problem was a weight problem. All right, so different things can happen, different issues can happen. These are all examples. All right, it will give you recommendations, and we can use those recommendations and go deep. Okay, but what are some of the recommendations? They will tell you that you need additional processors. It may ask you to do something, increase parallelism. But if you don't have the processors to do that, what are you going to do? It may tell you to change the parameters, database, all right? Again, whenever it's giving you all of this, always try to put it in your mind, like, what aspect of tuning are we doing now? Is it SQL tuning? Is it instance tuning? Is it this tuning or is that? Sometimes it could multiple things that you need to do. We need to fix the SQL as a tuning advisor. While you create an index, you may also need to increase the size of buffer cache. In that case, it may take 2 elements of tuning to get you the final good result. There may be schema changes. You know, like we said, we'll do on Friday. What that partition? Say, go and create a partition. You're querying all your data from one quadrant of that table. Why do you create the table? Why are you querying the entire table? You can query fewer results. You get the result faster. All right. I'm giving you too many examples of the partition. All right. Application changes. Or sometimes you may log on to other advisors to give you advice from someone else. Okay. See the advisors that you have. So that is diagnostics. Now we come to advisory. Advisor. The advisory framework. Coming from where?
ADDM.
Diagnostics. Right? SQL tuning advisor, SQL access advisor. In different ways that SQL can be tuned. How do you access the data? Why are you accessing the data from the table when you can access it from an index? Why are you accessing from the table you can access it from a partition? Remember I told you something like this. Partition. I think we had a table which had records in the table. All right, let's do this is right. Let's do save. Told you that we can have a table with table can be like this, and we call this table PIPG, right? The people in PG County. You run a query to see the people who are in kindergarten, right?
Yes, sir.
I can make this right and call it P1. We can call this P2, partition 3, and P4. We can create a range partition. If you color from kindergarten, everybody from here to here is what? 1 to 25 years old, right? 26 to 50. 51 to what?
75.
75, 76. So if you are running a query, all right, this entire table has what? 5 million rows. But this first partition has what? P1 has what? 1.2 million, right?
Yeah.
Which will you rather query? You have room for people who is in kindergarten who's above 25 years old. Would you rather query from the entire table itself? Or want to query from PIPG P1?
From P1.
So that is a partition. It makes your query faster because you still get all your results, right?
Yeah.
But now you're querying from less data. That's called a range partition. You don't have to do it for everything.
So a quick question.
Yes.
Can we back up our table based on the partition?
Can you back up a partition?
Yes. Like
yes.
Yeah.
You can.
Okay.
Can you export a partition? Yes, you can.
Really? Like you can export P1 and keep the P2, P3, and P4.
No, I want to use just P1. Why do I have to partition? Why do I have to use the entire table? Do you understand?
Yes, sir.
If what I want to send to you, you say, let me have an export and say, why am I sending you an export of the entire table when all we're looking for the thing that I found in P1?
So you're kind of breaking.
Yeah.
You're kind of breaking.
Breaking one now. I'm asking you if I can, why would you want to export 5 million rows when all the records you are interested in is in 1.2 million rows? Does that make sense?
Yes.
That's why I would say we can just export this one and we'll get all our data we're interested in. Partition is what? Part of a table. But it must logically make sense why it is a partition. Again, we're saying those who are here from what? 1 to 25 years. Your query you are running is for kindergarten, and nobody's 25 years above kindergarten. Are we following?
Yes, sir.
All right, so we have our SQL tuning advisor. It can help us to tune SQL access advisor. So you see where we access the data from a partition and it was better. Right? It is cutting your query into half, 1/4. We also have memory advisors. When you talk memory advisors, we're talking what? EGA advisor, SGA advisor. An SGA advisor, buffer cache advisor, shared pool advisor, Java pool advisor, streams pool advisor, giving us memory. We've already seen some advisors. We've seen undo advisor, right? We played with undo advisor before, and that managing undo. Before put a fixed table space, we went there. What about segment advisor? What will segment advisor guide us on? Segment advisor, what is it gonna help us on? Who can give me an example of when segment advisor will help us? Or what is it advising us on?
I think it looks for the tables and indexes that consume more spaces than required.
Absolutely, that's very good. You look for tables and indexes that consume more space than are required. Like what? Who can give me an example?
No.
You see these two tables?
Yes, sir.
Table A and table B, which one is better created? Table A and
But
table A is better created.
yeah,
Why?
because
It contains one small table space and automatically resize itself if it needs more space.
Where do you see that?
The top part of it is small, and then
So you say it contains what?
More free space.
because
More?
the free space
More free
on the
space.
Table A contains more free space.
no, the free space on table A is smaller than the number of rows on that table.
Yes. Some people are saying that they see more free space in table A.
Table B is the one have more free space
Yes.
than the amount of the row.
Absolutely. This is free space, right? This is free space. So which one will not be created well? It's not created well. B, right?
yeah.
So I think segment advisor is going to walk around and look for tables like table P and recreate them so that they have smaller free space. Because they are wasting space. Other people may need it. What else? Segment advisor will also go around and look for, like due to updates and deletes. Let's look at table C. Due to updates and deletes, we'll start having free space here, right? Are we following? Are we good?
Yes, sir.
Yes, sir.
So this guy will go around, segment advisor, and do what? Coalesce all of this, right? Put them together. We don't. Oracle doesn't want to get its free space in little chunks, and when it puts them together, it's going to drop down the right. It's
Yes.
going to drop down our new row data, and then but we are going to maintain this. Know this one up, maintain it because it's what? The high water mark, right?
Yes.
Because that's the point at which data had been at some point. Are we following?
Yes,
So
sir.
Yes, sir.
segment advisor will, one, look at those tables that are not properly created, and two, it will go and coalesce all the free space to make it one chunk of free space. All right, I'm done for today. Entire two. Here we're just talking about multiplexing. We do log files and making them bigger. I said, how will you do that? Somebody will create 3, 4, 5, and 6 bigger ones, and then take this one offline, offline, offline. And you're left with 4, 5, and 6 big ones. All right, folks, I'll see you.
Thank you, Prof.
Thank you.
Thank you.
Is this making any sense to anybody? Are we revising?
Yes, sir. A lot.
All right.
Yes.
I want to make performance tuning easy for you, because if it is, you have held the most important part of this thing.
Some of these things are just like new.
Why were they new when all of you have done now?
I know. So you know, when we got to this topic in DB1, man, a lot of that was when coronavirus started.
everything now you blame the virus.
Buffer cash full.
Buffer cash was full.
Yeah.
I feel that.
Too much information.
I want the day you tell me too much money. Prof, take some of it.
I was missing in class.
Huh?
We miss in person teaching.
Oh, you miss in-person teaching?
No, I miss you in person teaching.
Oh, me in-person teaching?
Yeah, like in class.
We have to go and bring the young ones up now. You guys already had 3 months of babysitting class. So now we have to come and do. Well, some people don't miss me, so I will not come again.
No, pre-prof, come.
They have not opened their mouth to say one thing. It's because they miss you. They are saying this bad man again. I'm not serious. Hi, people.
Are we here Friday, Prof?
I don't know yet, but I'll let you know. But plan on it.
Okay.
Even if it is even if it's a short one, just plan on it. But we'll try.
Is there any homework?
Yes, for the homework, I want you to actually do those words again, because I want us to kind of go through them. You understand? And really understand them. So do your best in not just define it, right? But give me a couple of lines. Like if anything has come, like I say AWR, what is AWR? Automatic Workload Repository. It stores database statistics. It contains 2 sections, an in-memory section and a file section which is stored in the sys table space. It is copied from memory there by the M1. You understand what I mean?
Yes.
Just a few things like that. Give me a few 3-4 sentences on each of those. Let's see how we can go. If we go into DB2 understanding those words, it really helps us.
Okay.
Especially understanding our top to bottom approach already. And let's try to, what we're going to try to do is to try to associate all of those words into different aspects of performance tuning.
All right.
All right, good.
All
right, folks. Have a good night. Take care.
Thank you, Paul. You too.
All right, bye-bye.
Bye-bye.
You wash up. Listen.